People hear the word field in physics and immediately imagine something mysterious, abstract, and frankly, suspicious. It sounds like something you're supposed to nod at politely without really understanding. That's a shame, because fields aren't mystical at all. They're actually one of the most honest ideas physics has ever produced. Let's start simple. Forget equations, forget fancy words. Imagine space. Not empty space as a philosophical idea, but real space, the kind where things happen. Now imagine that space can have properties, not objects. Properties, that's it. A field is just a way of saying, at every point in space something is going on. Take temperature. In a room, the temperature isn't stored in one place. Every spot in the room has a temperature. If you move around, it can change. That's a field. Nobody panics when we talk about temperature fields, but say electric field and suddenly everyone freezes. Now consider gravity. You could say objects pull on each other, fine. But that idea becomes awkward when nothing is touching anything. So instead, think of gravity as something that exists everywhere. The Earth doesn't reach out and grab you. Space around the Earth is already prepared to tell objects how to move. That preparation, that instruction manual written into space, is the gravitational field. Fields are not excuses. They're bookkeeping tools. They tell us at each point in space what would happen if something were placed there. That's all. The beauty of fields is that they remove magic from action at a distance. Nothing jumps across space instantly. Space itself does the work. If a charge moves, the change doesn't teleport. It spreads, slowly, lawfully, respecting the universe's speed limit. And here's the important part. Fields are more real than particles. Particles come and go. Fields stick around. Even when there's nothing there, no charge, no mass, the field still exists, waiting, quiet, patient, ready to act if something shows up. People often ask, but what is a field made of? That's the wrong question. A field isn't made of anything in the way a chair is made of wood. A field is a description of how nature behaves. Asking what it's made of is like asking what a rule is made of. It's not made, it's followed. Once you accept fields, physics suddenly becomes reasonable. Light, a vibrating electromagnetic field. Forces, interactions between fields, even particles themselves, little excitations, wiggles in underlying fields. So when you hear field, don't imagine fog or invisible strings. Imagine a map of space telling you point by point what nature plans to do next. And if you can picture that clearly, without equations, without fear, then you don't just know the word field. You understand it. When people hear the word field, they often react as if they've been handed a mystery they're not supposed to understand. The word sounds technical, abstract, and distant. Something that belongs on a blackboard covered in symbols rather than in your head as a clear idea. But that reaction comes from the word, not from the concept. A field itself is not mysterious at all. In fact, it's one of the simplest and most honest ideas physics has ever come up with. To see this, forget physics for a moment and think about everyday experience. Imagine walking across a room. As you move, the temperature around you might change slightly. Near the window, it's cooler. Near the heater, it's warmer. At every point in the room, the temperature has a value. You don't need to touch anything or interact with a special object to experience it. The temperature simply exists everywhere in space. That pattern of values spread across space is what we call a field. Nobody finds this strange. Nobody asks where the temperature particles are hiding. We accept it because it matches our experience. A physical field works the same way. When we talk about an electric field, for example, we are not inventing invisible ropes or ghostly forces reaching out from charges. We are simply saying that space around a charge is different from empty space far away. At each point, space carries information about what would happen if another charge were placed there. That's it. No drama, no mystery, just a description of how nature behaves point by point. The trouble starts when people expect a field to be a thing you can hold, like a rock or a ball. But a field isn't an object. It's a description. It's a way of keeping track of what space is prepared to do. If you insist on imagining it as a physical substance, you'll get confused, because that's not its job. Its job is to tell you the rules locally, right here, right now, without needing anything far away to act instantly. This idea becomes especially important when we think about forces acting across empty space, saying that one, Object pulls on another from far away sounds almost magical. How does it know the other object is there? How does the influence travel? Fields remove this magic. Instead of one object mysteriously reaching across space, we say that space itself carries the influence. The presence of an object changes the surrounding field, and that change spreads outward in an orderly way. When another object responds, it's responding to the field right where it is, not to some distant command. Once you think this way, the universe becomes more reasonable. Nothing needs to cheat. Nothing acts instantly. Everything happens locally, step by step, according to simple rules. Fields are the bookkeeping system that makes this possible. What's even more interesting is that fields don't disappear when nothing is happening. Even in empty space, the field exists. It may be quiet, doing nothing noticeable, but it's still there. The moment something enters that region of space, the field already knows how to respond. In that sense, the field is more fundamental than the objects that move through it. Objects come and go, the field remains. So when someone says a field is mysterious, what they're really saying is that they've been distracted by the language. Strip away the intimidating word, and you're left with a very simple idea. Space has properties, and those properties matter. A field is just our way of describing those properties clearly and honestly. Once you see that, the mystery doesn't deepen. It disappears. For a long time, people were comfortable with the idea that objects could somehow influence one another across empty space. One thing moves and another thing far away responds, as if the message were delivered instantly by magic. It works well enough for everyday intuition, but the moment you stop and think about it, the idea becomes unsettling. How does one object know the other is there? What carries the influence, and how does it respect the fact that nothing in nature can act faster than a certain speed? This is where the idea of a field quietly steps in and removes the mystery. Instead of imagining objects reaching across space, think of space itself as the stage where everything happens. Space isn't just an empty container where events take place. It has structure. It has rules. When an object is present, it doesn't shout across the universe. It simply changes the condition of the space around it. That change is local, right where the object is, and then it spreads outward. Other objects don't respond to the distant source directly. They respond to what the space around them is telling them to do. This shift in thinking is crucial because it replaces action at a distance with local cause and effect. Nothing jumps. Nothing cheats. Every interaction happens where it happens. If something changes here, the effect travels through space, passing from point to point until it arrives somewhere else. That journey may be fast, but it's never instant. The field is the messenger, and it always obeys the rules. Consider what happens when something moves or changes. The effect doesn't appear everywhere at once. The surrounding field adjusts first, then regions farther away adjust later. This simple idea explains why influences take time to propagate and why there is a universal speed limit. Without fields, you would have to invent complicated stories about invisible forces acting instantly. With fields, you don't need stories at all, just patience. What's remarkable is that once you accept this picture, many different phenomena suddenly look alike. Electric effects, magnetic effects, gravitational effects, all of them follow the same basic pattern. Something alters the field in its neighborhood, and the field carries that alteration outward. Other things respond locally, based only on the field where they are. The universe becomes a network of local conversations rather than a system of long-distance commands. This way of thinking also protects us from fooling ourselves. If you believe in action at a distance, you can hide ignorance behind words. You can say it just pulls and stop thinking. Fields force you to be honest. They demand that you explain how changes move through space and time. If your explanation violates the rules, the field picture exposes the problem immediately. There's also a deep simplicity here. Once you describe the field everywhere, you no longer need to worry about what every object is doing to every other object. Each object only cares about the field at its own location. The complexity of the universe is spread out smoothly across space instead of being tangled up in countless pairwise interactions. This makes the laws of nature not only more accurate, but more elegant. In the end, replacing action at a distance with fields isn't just a technical improvement, it's a philosophical one. It tells us that the universe works locally, honestly, and without shortcuts. Space itself plays an active role, carrying information, enforcing limits, and making sure that cause comes before effect. When you say that clearly, the old idea of mysterious forces reaching across emptiness starts to feel unnecessary. The field does the job better, and it does it without magic. It's very tempting to think of the world as being made only of things you can point to. Little bits of matter flying around, bumping into one another, and causing events by direct contact. That picture feels solid and comforting. But the deeper you look, the less adequate it becomes. You quickly run into situations where nothing seems to be touching anything, yet effects still occur. This is where the idea of fields earns its place, not as a strange invention, but as a necessary clarification of how nature actually works. A field is often misunderstood as an object hiding in space, but that misunderstanding comes from trying to force it into the same category as particles. A field is not something you pick up or push. It is a rule book written into space itself. At every point in space, the field tells you what would happen if something were placed there. It doesn't need the thing to exist in advance. The instructions are already present. Think about it this way. If you drop an object from a certain height, you don't need to ask whether gravity has noticed the object yet. The behavior is already decided. Space around the Earth is arranged in such a way that falling is the natural response. That arrangement is the field. It's not reacting, it's already prepared. This idea becomes even clearer when you realize that the same field can guide many different objects at once. You don't need a separate instruction for each one. The field doesn't care who is listening. Anything that enters that region of space responds. DS according to the same local rules. In that sense, a field is democratic. It treats all participants the same way simply by existing. What's important here is that fields allow us to separate cause from response. The source of a field may be far away, but the response is always local. An object only reacts to the field right where it is. It doesn't need to know anything about the rest of the universe. This keeps physics honest. You don't have to imagine hidden messages being sent instantly across space. Everything happens where it happens, guided by local conditions. This way of thinking also explains why fields can exist even when nothing seems to be happening. A calm field is still a field. The absence of motion or interaction doesn't mean the absence of structure. Space can be quietly full of rules waiting to be tested. The moment something enters, the response appears, not because the field wakes up, but because it was always there. Another powerful idea follows from this. Objects are not as fundamental as we once thought. What we call a particle can be seen as a small disturbance, a ripple in an underlying field. The field comes first. The object is just something the field is doing. This reverses the usual picture and makes the universe feel less like a box of parts and more like a continuous fabric that can vibrate in different ways. When you accept that, many puzzles disappear. You no longer ask where the force comes from at the exact moment it acts. You know the answer already. It comes from the field at that point in space. You don't ask how different objects coordinate their behavior across vast distances. They don't coordinate at all. They simply obey these same local rules. So the power of a field is not that it adds complexity, but that it removes it. It replaces mysterious interactions with clear local instructions. It allows space itself to carry meaning. And once you see a field as a set of rules rather than a ghostly object, the picture of nature becomes simpler, cleaner, and far more satisfying. When people first encounter the idea of a field in physics, they often ask the wrong question: what is it made of? That's understandable. Our instincts are built to look for tangible objects, things we can see, touch, or hold. But a field is not a thing in that sense. It is a description, a pattern, a set of instructions embedded in space itself. Thinking of it as made of something leads to confusion, because it's not a substance. It's a way of representing how nature behaves at every point. Asking what a field is made of is like asking what a rule is made of. A rule doesn't have material, it simply exists and is followed. A field tells you what happens if you place something somewhere. That's its entire job. It doesn't need anything present to exist, and it doesn't change depending on whether anyone notices it. Space, when described by a field, is already primed to produce behavior. Imagine an empty patch of space near a charged object. The space there is different from the space far away. If you bring another charge into that region, it feels a force. The space didn't need the second charge to act correctly. It was already structured to respond. This is the essence of what a field does. Thinking of fields in this way also eliminates a lot of apparent mystery. Long ago, people imagined that objects acted on each of her directly across empty space instantaneously. One rock pulls on another, one planet attracts another, and somehow they know where to apply their influence. That idea works for rough approximations, but it breaks down under careful inspection. Fields remove that puzzle. There's no need for magic or instantaneous communication. The influence of an object is carried through space by the field. Nearby regions of space respond first, then regions farther away, and everything obeys the rules of locality. There is no cheating, no action at a distance, just simple, step-by-step propagation. The more you consider this, the more natural it seems. Take light, for example. It isn't a stream of particles shooting randomly through empty space. It is a wave traveling through an electromagnetic field. The field carries the information, guiding the energy from place to place. Nothing is reaching across space to push anything along. The wave simply moves according to the local properties of the field. Everything becomes coherent, logical, and predictable. Another remarkable aspect is how fields redefine what we consider fundamental in the universe. Objects, particles, even forces can all be seen as disturbances or excitations of underlying fields. Particles are ripples, fleeting patterns, temporary manifestations of a continuous medium that pervades space. The field is the constant, the background structure, and the particles are the temporary actors. This flips our usual intuition on its head. The field comes first, the object comes second. Space is not empty, it is a stage actively shaping events. Fields also unify seemingly different phenomena. Gravity, electromagnetism, and other forces may appear unrelated at first, but they all operate as fields. Each one tells space how to behave, and each one responds to disturbances locally. With this framework, the universe is no longer a collection of isolated objects tossing forces at one another. It is a smoothly connected network where cause and effect follow clear local rules. Understanding one field gives insight into another because the underlying principle is the same. The behavior of space governs the behavior of matter. Ultimately, thinking in terms of fields shifts how we understand reality. It encourages honesty, clarity, and simplicity. Instead of imagining mysterious, invisible forces or objects acting instantaneously across distances, we see the universe as local, structured, and obeying rules consistently. The field is always there, always ready, providing a clear instruction manual for what happens at each point in space. When you grasp this idea, physics ceases to be an intimidating maze of equations and abstractions. It becomes a logical, coherent picture of nature, simple, beautiful, and profoundly satisfying. Once you start thinking about fields in physics, one of the most striking realizations is how they make the universe far more elegant and simple than it first appears. For centuries, people tried to understand nature by focusing only on objects, particles, rocks, planets, and other things you can point to. That approach works for many everyday problems, but it falls short when you try to explain what happens at a distance or in situations where objects aren't touching. Fields provide a new perspective, one that reveals a deeper structure underlying all interactions. A field exists independently of whether anything interacts with it. It doesn't need an object to make it real, nor does it vanish when an object leaves. Space itself carries information about what would happen if something were placed at any particular point. This is why fields are so powerful. They provide a complete description of the behavior of nature at every location, whether or not anything is currently present. You can think of it like a map. A map doesn't need travelers to exist in order to show where the roads and rivers are. It simply describes the layout of the terrain. Similarly, a field describes how forces and influences are distributed in space. One of the most important benefits of thinking in terms of fields is that it eliminates the need for mysterious action at a distance. In the old way of imagining physics, one object somehow knows that another object exists far away and pulls on it instantly. That idea might be convenient for basic calculations, but it defies common sense and violates the fundamental principle that information cannot travel faster than a certain speed. Fields remove that problem entirely. Changes in the source of a field propagate through space, point by point, influencing other objects only when the field reaches them. Nothing leaps across empty space magically. Everything happens locally. This makes the universe far more intelligible and predictable. Fields also show us that particles and objects are not as fundamental as they appear. A particle can be seen as a small disturbance or ripple in an underlying field. It exists because the field is behaving in a particular way at a particular point in space and time. The field is continuous and pervasive, while the particle is temporary and localized. This perspective transforms our understanding of reality. The building blocks of nature are not isolated objects, but the fields themselves. Everything else, particles, forces, interactions, emerges from the behavior of these underlying structures. Another remarkable feature of fields is their universality. They allow us to describe many different phenomena, electromagnetic forces, gravity, even aspects of quantum mechanics, within a single framework. Each type of field has its own rules and behaviors, but the underlying principle is the same. At every point in space, the field specifies how objects respond. This consistency simplifies physics enormously. Instead of needing separate explanations for every type of force, we understand that nature follows a coherent set of local rules. The universe is less a chaotic jumble of interactions and more a structured, interconnected system. Fields also exist even in empty space. That is, even when no particles or objects are present, the field is still there, quietly defining the potential for interaction. The moment something enters the space, the field is already prepared to guide its behavior. This reinforces the idea that fields are not secondary to objects. They are the primary framework within which everything occurs. The presence of matter simply highlights or excites the field. It doesn't create it. Ultimately, understanding fields changes the way we perceive nature. It shifts our focus from trying to describe objects alone to understanding the structure of space and the rules that govern it. Fields are not mysterious, not magical, and not intangible in a confusing way. They are simply the clearest way to describe reality as it actually is. Once you think this way, physics becomes less out memorizing formulas or imagining strange forces, and more about understanding the consistent, local, and elegant rules that shape everything in the universe. The field is always there, silently guiding the behavior of matter, and recognizing this is one of the most profound insights physics has to offer. True understanding in physics doesn't come from memorizing equations or repeating phrases. It comes from being able to see things clearly in your mind and explain them simply. This principle applies perfectly to fields. To really grasp what a field is, you don't need complicated mathematics or abstract symbols. You need a clear picture of what the field does and how it influences the world. A field is essentially a way of describing how nature behaves at every point in space, and the remarkable thing is that once you understand it this way, it becomes intuitive rather than mysterious. At every point in space, a field tells you what would happen if something were placed there. That's the entire purpose of a field. It doesn't need to be observed to exist. It doesn't change depending on who is looking. Space itself is prepared in advance to act in accordance with the field. Imagine an empty region near a source of influence, like an electric charge. Even before another object arrives, the space surrounding the source is already ready. It has the rules built in, the instructions set, the potential established. When another object enters that region, it simply follows those instructions. The field is not doing anything reactive. It has already encoded the outcome. This is why fields are more fundamental than the objects that move through them. Particles and objects are temporary manifestations, whereas fields are persistent. Thinking in terms of fields also removes much of the apparent complexity in physics. If you try to describe interactions only in terms of objects, you end up with a tangle of forces acting at a distance. One object pulls on another, yet they might be separated by space that seems empty. That approach works in simple situations, but it raises the question, how do these influences travel? What is connecting the objects? Fields solve this problem naturally. They carry information locally, point by point, and the response of an object is always determined by the field in its immediate vicinity. Nothing jumps, nothing communicates instantaneously. Cause and effect remain local, and the universe becomes logical rather than magical. The clarity of fields extends even further. Different kinds of interactions, electromagnetism, gravity, quantum effects, can all be understood as fields. Each field provides a set of rules governing the behavior of objects and particles within it. Once you adopt this perspective, the universe no longer seems like a collection of independent forces competing chaotically. Instead, it appears as a coherent, interconnected network of local rules. Every effect, every interaction, every particle is guided by the underlying field that defines its environment. Fields also demonstrate that empty space is not truly empty. Even where there are no particles or objects, the field still exists, quietly defining possibilities and constraints. Space is never passive. It is always structured, always carrying information about how things will behave. This means that reality is not a patchwork of isolated objects acting independently, but a seamless, continuous fabric where behavior emerges from the structure of the field itself. Particles, forces, and interactions are all disturbances in this fabric, temporary ripples or excitations in something that is fundamentally continuous. Ultimately, the power of the field concept is that it encourages honest, clear thinking. It forces you to think about what actually happens, rather than hiding behind vague notions or mystical forces. A field is not something you need to visualize as a substance or a thing. It is a map of reality, showing how nature behaves point by point. Once you understand this, physics ceases to be intimidating. You no longer need to memorize abstract rules without comprehension. Instead, you see a coherent, elegant picture of the universe where every interaction makes sense locally and everything follows clear, consistent principles. Fields turn confusion into clarity, mystery into understanding, and abstraction into something you can truly picture in your mind. This approach, seeing clearly, thinking locally, and explaining simply, is what allows true understanding. When you look at the universe through the lens of fields, you don't just know the words electric field or gravitational field. You understand what's happening in space itself. You understand that particles are temporary excitations, that space is structured, and that local rules govern everything. And that understanding is what transforms physics from a collection of equations into a coherent, intuitive story about how the universe works.